So I'm here at ISEC in Seattle with Marie-Josee Fortin. So thanks for doing the interview.
Welcome.
So you've recently published a paper in MEE, it's in press, on state of transition models. So
Right.
could you tell us a bit about it?
Yes, this is the work of my PhD student, Collins Daniel, that is interested in modeling both land use change, cover change with states transition. And the method can be very flexible to be used with other contexts where you have states. So you can have a species composition community structure. So let's say in our borough forest, it would be spruce budworm are attacking black spruce or Bowsen farm. So you can really have those state of community structure and have transition between them. So he's adapting this method to have forest stochastic disturbance, fire, climate change, so on and so forth. In the paper, it's just an illustration of the power of the method because unlike Markov chain, this state and transition modeling framework allows to have disturbance and change the condition of your transition. So they're not static, they don't depend on the previous step. You can impose anytime in your simulation new component of stochastic disturbance. So it's very flexible.
Okay. So like with a transition matrix modeling approach, like so you say it's different from the Markov models because you can have changes of state. You can change the rules for the transitions.
Right, exactly.
You can kind of already do that a bit by having a set of different transition matrices, but
Right.
it is a distinction here that it can be different in different states and different places.
Yes, exactly. It's really localized. You can have some region that are affected differently than other because it's very spatial explicit in a sense.
Yeah, right. Cool. So who should read this paper?
I think definitely nowadays people that are interested in carbon sequestration, climate change, land use change, and want to model those phenomena. It's a very good paper. So researcher, established researcher, and grad student, of course, because they are the ones that are more maybe able to use it directly in their thesis and then profit from this kind of framework. So it's really a framework.
Okay, yeah, right. Good. So I'd also like to talk a bit about you.
Yes.
Okay. So you've been in sort of spatial ecology, so
Yes.
numerical ecology for a fair while now. I guess I was curious, first of all, what got you involved in this area in the first place?
Oh, well, first I wanted to go to mathematics.
Right.
And I find it too abstract.
Mm.
So I wanted something more applied, and to merge ecology and statistics was a good opportunity. And because our landscape are so dynamic, especially and temporally, spatial statistics reflect really the landscape in which species need to survive and move. So that's where I was very interested in modeling in space processes.
Yeah, fair enough. Okay. So, what do you think's changed in the time that you've been involved in the field? Sort of, how do you think? What do you think are some of the big changes?
Well, from a statistical perspective, we had to deal with homogeneous areas where the processes were stationary and knew mostly what they were, to now have a large area where everything is non-stationary and you have change of processes, like I just mentioned. So basically now we need to embrace spatial temporal dynamic and that those dynamics are not stationary. So it's imply new vision of how to analyze it and or to recreate where are the regions that are homogeneous. So you need method to say, well, in that large context, maybe I need to study a sub-region that is stationary in some way. So we need to find back where are the regions that are stationary.
Okay. And in terms of sort of big challenges, what's sort of something that you're excited about that you see as sort of a big, or have we already covered it?
Well, I think space and time is the next frontier because we have more and more time series of data, and we need to have statistics that can tell us is the joint distribution of space and time. It's not just how to test those because now it's a combined distribution, so it's a little bit more complex. So will require people more clever than I to solve this one.
Yeah, me too.
So I think this is where, because we have ways to describe the processes and quantify them, but are they different from random?
Yeah.
So again, it's back to are they stationary? What is the break in the behavior in space and time? So I think that's the next step.
Yeah, brilliant. There has been a bit of space-time talk at ISEC.
Yes.
Like I've seen a couple of talks today. I think Jim Thorson and Jay Verhoeven.
Jay Verhoeven, yeah. That was a very good talk from Jay Verhoeven today. So I think we have start now to see more and more people addressing those issues.
Yeah, brilliant. Okay. Well, it's been a pleasure.
Okay.
Merci beaucoup.
Oh, à la prochaine.